This is 5.3 on special product of binomials. We're gonna do a little example here on just multiplying binomials. So I have x plus 3 times x minus 5. You can either do the box method, which the box method is draw a little box. Both of them have two terms. There's my little box. So that's x, that's plus 3, that's x, and that's minus 5. And then what we're going to do is we are going to multiply what makes up that box. So that first box in the top left is x times x, which is x squared, right? And then x times negative 5 is negative 5x, okay? And then 3 times x, which is 3x. And then 3 times negative 5, which is negative 15, right? So when we multiply this, we gather in the like terms, and your like terms will always occur in this box and in this box, okay? The 3x and the negative 5x, so that's minus 2x. If you add them up, 3 minus 5 is negative 2, and then minus 15, right? So then that's the box method. Another way we can do this is via FOIL. Okay, FOIL just stands for F is first. So we get the first terms of both binomials. So that's x times x, which is x squared. The O in FOIL means outer or outside. So we're going to get the outside two terms. So x times negative 5, which is negative 5x. And then I in FOIL means inner or inside. That would be 3 times x, which is plus 3x. And then the L is last, which is 3 times negative 5. So we just get the last terms of both binomials, which is negative 15. And then we simplify it by putting these two guys together. So that's x squared, negative 5 plus 3, again, is negative 2x, and then minus 15. Okay, so either way works when you're multiplying. It doesn't matter which way you use. As long as you guys multiply correctly, you guys should be fine. Okay, but this 5.3, we're talking about special product of binomials, where we have a special product whenever it's squared. Okay, whenever a binomial, like let's say x plus 4 is squared, we're always going to have a special product. So there's a special formula which you can bypass the multiplication of it, okay, and just use the formula itself. But I'm going to multiply just to show you guys this. X plus 4 times x plus 4. Okay, if we FOIL or box method, same thing. I'll use the foiling in this case, and then the next example we'll use box. So we'll use both ways. So I hit everybody's preferences. F is first, so x times x is x squared. O is outer, which is x times negative or plus x times 4, which is plus 4x. I is inner or inside, x times 4x, or x times x is 4x again. And then L is last, so 4 times 4 is plus 16. Gathering the like terms again, that's x squared plus 8x plus 16, correct? Yeah. So here, x plus 4 quantity squared equals x squared plus 8x plus 16. Right? Okay, any questions on this so far? And what I want to derive is what if in generic form, instead of x, it's a, instead of 4, it's b, right? How does x squared relate to x plus 4? Why don't you guys try and come up with a generic form here? Okay, I'll give you guys about 3 minutes. Talk to your neighbors. Try to brainstorm. How do I get, or what does a plus b quantity squared break out to be? Yeah, a plus b quantity squared breaks out to be a squared plus 2ab plus b squared. Okay, notice that 4 times 4, we got 16, right here. X times x, we got x squared here, right? And if it's the same binomial, x plus 4 quantity squared, 4 times x and x times 4, the outer and the inner of FOIL, is going to produce the same number, right? And since we got 2 of them, it says 2 times a times b. Okay? Does that make sense? So that is my first special form. A squared, a plus b quantity squared equals a squared plus 2ab plus b squared. Okay? That's my first one. We're good. Okay. All right. So what I want you to do is use that formula plus 5 quantity squared. If we use that formula, right, this formula here, to simplify or to multiply this, you don't have to use the box method or FOIL. You can just go. So that's the first term squared, right? First term squared, a squared, so that's x squared here. The last term is b squared, so that's 5 squared here. And then the middle term is going to be times 2a, which is x, b, which is 5. Right? So you have x squared plus 10x, because 2 times 5 is 10, plus 5 squared is 25. And that would be the product of x plus 5 times x plus 5. Okay? All right. So my second special product is a lot like the first one. X minus 3 quantity squared. That breaks out to be x squared, same thing, right? Square the first term, square the second term, put it in the back. And the middle term is going to be 2 times x times 3, right? 2ab. So that's x squared, 6x, and 3 squared is 9. Yeah. And the only difference is, since this is a minus class, I'm going to have negative 3x and negative 3x if I FOIL this out, right? So that becomes a minus 6x. Okay? And this plus is the same. All right? So the only difference in special form for number 2, a minus b quantity squared, that's going to just break out to be a squared minus 2ab plus b squared. Okay? The plus goes with the plus, the minus goes with the minus. That's it. Okay? All right? I'm going to throw something at you that you guys can see on your assignment. X squared minus 3y quantity squared, like that. Okay? Hold true to your special form. Okay, I'm just gonna put it up here so we can use it. A squared minus 2ab plus b squared, right? Remember, this is my a minus b, right? My b is 3y, my a is x squared. So a squared is gonna be x squared squared, okay? A squared is x squared squared. Minus 2 times a, which is x squared, times b, which is 3y, plus b squared. B is 3y, so 3y squared. Okay? I just copied it and pasted it, right? Got my a as x squared, got my b as 3y, and I just put it, substituted a and b for x squared and 3y into here. Okay? And then just simplify it. X squared squared. What do you do when there's two powers like this? No, multiply. So 2x or x squared squared is x to the 2 times 2, which is 4, minus 2 times 3, which is 6. And then this will be x squared y. And then plus 9, because the 3 squared is 9. Y squared is y squared. That would be my answer. Make sense? Yeah? Yes? That's fine. Because y squared is right here. Remember, this squared goes both to the 3 and the y. Yeah, it goes both. So 3 squared is 9. Y to the power of 2 is y squared. Okay? Cool? All right, so just work the formula and you guys should be fine. Okay? The third and final special form that we have is when we multiply the two same terms. So let's go with x plus 5 times x minus 5. When we have the two same terms, x and 5, and the only difference is the plus and the minus, let's FOIL or let's box method this. Okay, since we FOILed the last one. If I use the box method, okay, and then it's going to be x plus 5 and then x minus 5. X times x is x squared. X times 5 is 5x. Negative 5 times x is negative 5x. And then negative 5 times positive 5 is negative 25. Right? So that's going to be x squared. My like terms are negative 5x and 5x, which they just cancel out. And you're left with minus 25. Right? Okay? Because of the plus and the minus, class, we got the same terms, x and 5, x and 5. The only difference is the plus and the minus. That plus and the minus, 5 times x and negative 5 times x, they would cancel out. Always and forever. Okay? Yes. No? Okay. All right. So let's think about this in generic form. What if I gave you a plus b times a minus b? What would that be? What would that be? X squared minus 25, right? We got that when we multiplied these two, correct? So whatever relationship you guys see, try and apply it here. I promise I don't bite. Try to apply it here. I promise I won't point and laugh. How did I get x squared? What's the relationship between x squared and x plus 5 and x minus 5? How did I get x squared here? Multiply x times x, right? To get x squared. Yeah. X is my first term, correct? My first term in my generic form is a, right? So the first term here would just be a squared. Minus. How about the 25? B squared. Yeah. It would just be that. A squared minus b squared. Because those two middle terms cancel out. Okay? So there is my list of special forms. Okay? Work the formulas, right? And that's it when you multiply. Disclaimer, you can always fall back on foiling or box method. Okay, you can always just multiply. You don't have to use these. This is just a guideline, another way you can think about it. Does that make sense? Know them though, because you're gonna have to need them later. Okay? But you don't have to use them now to multiply. Cool? Questions on this? That's the lesson for today. That is 5.3.